I designed and I assembled the Quake Shaker motors for Stern pinball machines and WPC machines and for what was highway pinball machines, specifically Alien. So what I'm going to do is I'm going to run through actually putting together one of my motors. Now I actually use these motors. These are, if it will focus on that, come on, there we go. These are Johnson motors. These are the originals that were used throughout the 80s and the 90s by Williams for their games such as Earthshaker. Unfortunately, these motors are no longer available, so this is kind of my last hurrah. I've about 15-20 motors left, after which obviously I won't be making any more. So we'll run through, we'll put one together so you can see what's involved with it. So a word first of all about the actual motor in the shaker motor. Now obviously this is probably one of the two most important components, the other one being the actual weights and their design. So I've got a couple of motors. The first one I have is my Johnson motor, which I use. This is a 3200 RPM motor, 12 volts, 0.5 amp load, 2.5 amp max load. Now these are obviously ideal. This is probably why they were used by Williams. Unfortunately, as I say, these are no longer available. I've pretty much run out of stock. I've been all over the Eastern Bloc finding these motors, something out of Romania, Poland, Russia, places like that, and also most of them out of the US. So unfortunately, these are no longer available. You can actually get a motor which is a multi-products motor, but multi-products won't sell you just a motor unless you are somebody like Stern. So pretty much you're stuck with whatever else you can get. Now, a lot of places are selling shaker motors that are made out of something like this. This is an MFA or Como Motors motor. The biggest problem with these is twofold. The first one is the current draw. These will draw about 5 amps, which is a fairly good way to blow up any node board that you've got in your machine, just by the current draw alone. The second one is that this will actually run at 5800 RPM. So although the shafts and everything are the correct size, this is just going to run way too quickly. Now, a lot of people will tell you that what you can do is to put in some form of device, pulse width modulator. Sorry, excuse my problem pronouncing that. The problem with that is that it changes the actual behaviour of the motor. So just a quick little bit of theory. Here I've got a pad. So I'm going to draw in effect a sine wave. So my sine wave is going to look something like so. So this is a typical sine wave. If we are looking across the peaks, which will give us our pitch, this is the frequency. This is derived from the RPM of the motor, which gives you your hertz value. Okay, so as these get closer together, it's going to feel more like it's going to buzz. Which is what you're going to get, and this is where then they're going to turn down the speed to try and reduce the distance or increase the distance between these two. The next problem you have is you have the distance of the actual height of your sine wave, which will be somewhere over there. This is more governed by anything by the mass of the weight that's going to fit onto your motor. So this is going to give us the mass. The next thing you need to think about is the actual shape of the wave, which is going to come from the shape of your actual weight. The throw is from here to the end, which is also part of the distance on here. And also the problem you're then going to get is the shape it follows as it describes an arc around about the center point. This is going to change the shape of this wave here. So that is going to give you your wave shape. Now all of these things matter, and all of them are going to change depending upon what you're doing. So we need to think about the vibration or the feel, and that is going to be a product of these three items. So pretty much the feel is going to be the frequency multiplied by mass, and that is divided by the wave. So changing one thing is going to change all of the rest. So yes, you can put on here some pull PWM controller, and it is going to slow that down, but it is also going to affect everything else as well. As you reduce it, because it's been designed to work with a certain weight and a certain speed, that is also going to change the voltage and the amperage it's going to use. So once again, it's a good way of blowing up your machine if you're not careful. Obviously it does work, people are doing this, but I certainly wouldn't recommend it. So I'll be using these motors. When these motors are gone, pretty much I'll be stopping making them, because there is no good way of making sure that you're not going to blow your machine up. So we'll start in with this motor. We'll take account of this. This is how we have designed these parts. All of these have been taken into account. I've got several hundred of these motors out there. Never had a single return. So step one, the first thing we're going to do is we are going to take our motor. I have already dimpled these, whether you can see that or not. I've put these in my CNC machine. I've dimpled both ends. They don't come like that. Some do come with flats on. I don't like to use the flat, because if you're screwing onto the flat, the part can actually come off the end. With a dimple, not only is it actually fitted on there, but it's mechanically locked in place. You have to bear in mind that this is going to vibrate. Vibration makes things come loose. So thereby I like to dimple these, and I'm going to use a cone point set screw actually in there to fit them into place. I'm going to fit these in using these two end brackets. Now when I design this, I always, if I can, design it so that there are no handed parts. Any designers out there will probably tell you that if you design handed parts, it's going to increase the cost. And the reason it's going to increase the cost is because anybody that is making these will have to tool up twice to actually manufacture them. So wherever possible, I like to make these non-handed. So they're even all folded the same way. Batch production makes things a lot cheaper. It's often cheaper to make 10 of something than it is to make actually one of them. So I've designed and made these. I've had these laser cut out of aluminium. They did used to be steel, but to be honest, there is no point making them out of steel. You then, once you have it out of steel, you've got to think about plating it to stop it going rusting. That also then incurs a cost. These are obviously an indoor part. They are not going to see a lot of water or anything like that. It's going to be an electronic machine. Even just the heat of the machine alone is going to stop it going rusty. That said, cheaper to get them made out of aluminium, and also it is therefore cheaper to fold them. So once again, what I've done is I've drilled and tapped a few holes in here. Some of the holes within here are done for clearance. Some are done to allow air to be drawn through the ends of the motors. And of course, two of the holes are there for us to actually screw it into. So I've had these made, laser cut, I've folded them and I've tapped them. I could have got them to do that, but once again, they want to charge money for that. That's cost that I then have to pass on. So got the minimum done that I couldn't do myself easily, and then from there I will put them together. Now these parts, when they're put together, I've made the hole and the boss quite a tight fit, and the reason I've done that, as I say, is these are going to vibrate. If these move around, they are then going to elongate the hole. If they elongate the hole when they're being used, that's then only going to get worse. Eventually it's going to start rattling around. These are there for vibration. So everything is made to be a good fit. A little bit of trial and error with the tolerances when I had these laser cut to actually get them to do them exactly as I needed them. But I've been there. I've had 300, 400, 500 parts of these now off them. They know what they're doing, and they pretty much make a good job of it. So our motor is going to fit into the two ends. Now I am a fan, if I can, of making parts stressed. What I mean by that is that I will make a part such as this a structural part if I can. Now I've had to put two cross braces across to actually hold these parts together. If these were tapped in the back, I would have just screwed straight to the motor, and the motor would have acted as a spacer. Strength through lightness is one reason, and secondly, it would mean that I wouldn't need to pay out for another two of these parts. That obviously is cost. Even if they're, say, 50p a piece, that's £1 worth. If I'm making 1 million parts, that would be £1 million I'd saved. My boss would be happy, and it takes less time to assemble. So kind of this idea has come from the likes of Colin Chapman, Lotus Cars. he was a big fan of making stress components wherever he could. Admittedly, he went a little bit probably the wrong way, and some of the parts were a bit fragile. I'm not quite gone that far, but as I say, wherever I can, what I would do is I'll take these parts and make them structural. So, first things first, what I'm going to do is I'm going to screw this part using 2 screws onto our end bracket, making sure I'm getting it the right way around. It's dead simple. That's going to fit over to there, over the gap. Turn it around until the hole lines up, and then what I'm going to do is I am going to take a screw, which I should have over here, and we're going to screw that in. Now, as I say, this is going to be vibrating, so what we need to do is to put something on here to stop this vibrating loose. I could put a star washer on it, but what I am going to do instead, I'm going to use some Loctite, a thread locker. This particular one is not a liquid, and what I'm going to do is a little bit of a dab on the side of there. I'll screw it in, it will go off. You can tell when it's gone off because it goes kind of a pink colour, and then basically it's not coming out. Now, there are 2 screw holes in here. I don't use both screw holes, I only use the one. And the reason I do that, firstly, it reduces the amount of fasteners I need to pay for by half. Therefore, that's a cost I can pass on. Secondly, if I do need to get this out again, or let's say somebody needed to replace the motor at some point, they've only got the 1 screw to get out. Now, it's thread locked in. So if you've got 2 screws, that makes it equally difficult. But let's just say you couldn't get the screw back out and you had to cut the head off. What that means is you've got another hole over here that you can use, spin it round, screw it into the other hole, and it's still entirely functional. If I'd put 2 screws in, it wouldn't have achieved anything. It's not going to be any stronger because all this is doing is stopping this rotating, and it's going to do that using the shaft of the screw. It can't physically come off any other way because the boss is holding it in place. So all I'm doing is saving a bit of money on the fasteners and giving somebody a second chance if they need to get it apart to actually replace the motor, if they would ever need to, which they certainly shouldn't do. And now for my least favourite part of the job, and that's fitting these horrible 2 little spacers. I wish I didn't have to use them, so I could have probably made some that came off the back of here. We're kind of starting, we're building up a little bit of a module here, so we're going to be starting, this will build in effect this half of this side of the motor up, and then we'll build the other half, put 2 pieces together. Now, when I actually designed this, the way I made it was so that I didn't need to put a nut on the back here. And the reason I've done that is because the clearance between the motor and the actual side of the plate is quite tiny. And I obviously don't want to run the risk of this motor weight hitting the actual nut I'm putting on there. So I tapped it, which means that I need to then put a screw in from this side into that tapped hole. This is a little bit fiddly. I mean, certainly if you're making these in production, you'd probably come up with a better way of doing this. It's not too bad on the first side, but certainly when you put in the second half of the motor on, this can be a little bit tricky. That, and I may not have tapped the hole entirely straight because I did them using a pistol drill. My old teacher, Mr. Wardle, will kill me if he knew that, but I assume by this time he's long gone anyway. So, I'm going to screw these in. I don't thread lock these in. The reason I don't thread lock them in is these are actually not bent at 90 degrees. And the idea being is that when you tighten them up and it pulls them straight, it puts a little bit of what we call prevailing torque on them, and thereby it keeps them tight. If they fell off at the end, it really wouldn't be a problem anyway, because by that time you've already got it screwed down and everything is kind of held in place anyway. But yes, obviously I'm not going to do away with them. So first thing I'm going to do, I'm going to tighten these up. This is where an Allen socket normally comes in. That's really handy if you've got one of these Allen wrenches with the ball top on the end, such as these, because they allow you to get in at an angle. Unfortunately, the one that I want is missing, which is always the way. So what I need to do, I'm just going to tighten these up. I'm not going to go crazily tight with them because chances are I'm going to need to adjust them later. But as you can see, there is quite a bit of movement in there, and hopefully you can see that that part is actually at the moment less than 90. So when I put the other side in, you can see it's going to pull that over. That's going to put pressure on the inside of the head there, and that is in effect what's going to stop it coming undone. So one on either side. Once again, I've made sure these two parts are not handed. The idea being, as always, multiple parts that are the same, cost less than unique parts. So pop that in the other side, tighten that up if I can, and then this side of the motor is pretty much done. As I say, horribly fiddly. Might have to put that down and tighten these up. If I had my time again, I would redesign these. I'd screw it from the other side just because it's easier to get to, and I would alter the weight. But as I say, altering the weight will alter the harmonics, and thereby that will alter the feel of the motor. So not ideal. So screw that in and tighten that one up. As you can see, it's rotating around as I'm tightening it. I could have put 2 screws in it, which would have prevented that happening, but obviously 2 screws cost twice as much as putting 1 screw in. Now a lot of people have downed on people like Stern. They keep saying that they're cheapening out their machines, and that's a bad thing. In manufacturing, there's something called cost down. So what in effect you do is you take your design year upon year, you look at it, you rationalize it. What you try and do is you remove expense where you can. I'll guarantee that people want wage rises. Maybe your parts have gone up in price. People will not be happy if you pass that cost on. So one of the ways of making sure that you don't pass that on is through cost down. So a good example is the lockdown bar on Stern. Now people have a down on this. They say, oh, they've done away with all the receiver and it's horrible because I've got to undo 2 clips. Well, there's a couple of things on that. Think about the cost of that receiver. Probably to Stern, that's probably a $5 part. Once again, if you're making 1 million machines over the years, that would be $5 million. I don't think anybody complained if they came along and they gave you that. So, yeah, they put 2 clips on there. The clips probably cost them 50 cents. That's a huge saving. It does exactly the same job. Honestly, how often do you actually need to undo and take the glass out? Not that often. It's more secure. You can't lever the side up because it's now connected at both ends. So, well done, Stern. Keep it up. I prefer you stay in business and you carry on making machines, even if you have to make the odd compromise.